We're going to do some revision on quadratic simultaneous equations. So we'll copy this first one down while I'm doing a little bit of background talking about it. So this top equation is the equation of a circle. The circle has a radius of the square root of 13. That's something you'd explore more at A level. So when you move on to do A level, you'll look at the equation of a circle as being x squared plus y squared equals r squared. It is something that you'll see at grade 9 as well, but you do explore it further at A level. So we know this one's a circle, and x equals y minus 5. If I was to rearrange that so that it was in the form of the equation of a circle, y equals x, and I'll add 5 to both sides, so x plus 5, I can see that this would have a positive gradient of 1, so therefore no, it would be something like that. No, it won't go exactly through. That looks like almost like it's going through the center of the circle. It could go anywhere. But what I do know is that there'll be a point of intersection there and there. So when I'm solving these, I'm going to be working out 2 points of intersection. So therefore 2 answers. Unless, I guess, if it were the line was to go there, and then therefore that would be a tangent and there'd only be 1 point. But we'll see what happens as we do this. Okay, so if at these points the x and the y value of these will be the same, they'll be equal. So if I know that x equals y minus 5, but I also know that x squared plus y squared equals 13, so if I know that x is y minus 5, instead of writing this x here, I could substitute in y minus 5 because I know that's what x is. So y minus 5 instead of this x squared and plus y squared equals 13. So just to confirm what I've done there, I've written that top equation, the equation of the circle, but instead of writing x, I've written, because I know x is y minus 5, I've written it like that. And the reason I've done that is because now I have an equation that just has one variable in, the y value, rather than having an x and a y, 2 unknowns, and then it'd be too difficult to work out. So now I'm going to be able to get an equation which just has y values in. So what could I do next? I'm going to expand this, y minus 5 squared. So that would leave me with y squared minus 5y minus 5y plus 25. Okay, so I would expand that to 2 brackets. I could do it to one side if I wasn't confident, or I can do it straight away here. And I've still got plus y squared equals 13. Okay, so what would I do next with something like that? Well, I would tidy it up a little bit, wouldn't I? So I've got y squared plus y squared, so 2y squared. Minus 5y minus 5y would be minus 10y. And I've got plus 25 equals 13. Remember, I'm trying to solve this to work out what y is. So in order to solve, I need it to be equal to 0. So I'm going to subtract 13 from both sides. So I've got 2y squared minus 10y, and the 13 will come off here, leaving me with plus 12. And at this stage, we then need to solve the quadratic. We've got lots of different ways of doing that. We could use the quadratic formula. We could factorize it. We could complete the square. So there are quite a number of things that we could do. This one will factorize. Now, before I go and try and factorize this equation here, I could actually simplify it a little bit, because everything will divide by 2 here, giving me y squared minus 5y plus 6 equals 0, because 0 divided by 2 is also 0. And then it's just a little easier to factorize. So that's a nice little trick to use. So y, and I need 2 numbers that multiply together to give me plus 6, add together to give me negative 5. Well, if they're adding to make a negative, but multiplying to be a positive, they both must be negative, and it must be negative 3 and negative 2. So now I know that my y values are, well, y, and to make this bracket 0, y would have to have a value of 3, so y equals 3. And from this one, y equals 2. So I've got my y coordinates, and I've got 2 of them, remember, because there's 2 points of intersection. So the y coordinate of this one will be 2, the y coordinate of this one will be 3. I need the x coordinates for each pair. So I'm going to substitute in the fact that y is 3 and y is 2 into this equation here. So if y was 3, 3 minus 5 is negative 2. So there's my first coordinate. It'd be negative 2, 3. And if y was 2, 2 subtract 5 is negative 3. So I know that my second coordinate is negative 3, 2. So they're both my pairs. We'll do one more, something a little bit more complicated. Okay, so if we look at what's the same and what's different this time, we've got a circle still. This is the equation of the circle. The radius of this circle would be the square root of 27. I mean, we don't need to know that for this question, but this is also a straight line. But what's different this time is it's not written. The last one told me that x was y minus 5, whereas this one doesn't say x equals or y equals. So I can't substitute it in yet. So what I'm going to do is I'm going to rearrange it to make it say y equals or x equals. So if I made it say x equals, if I was going to rearrange this to isolate x, I would add y to both sides. So I'd have 3 plus y, or y plus 3. And then I would divide by 2. So that's one option. I could substitute that in for x. Not really keen on it having the divide by 2. Let's see what happens if I make y the subject of the formula. So I could add y to both sides, which would leave me 3 plus y equals 2x. But then I could subtract the 3. So I'd actually get 2x minus 3. And I think I'd much rather put 2x minus 3 in to y there. So that's what I'm going to do. So I'm going to ignore that one. And I'm going to substitute in 2x minus 3 for this y value. So let's write that out. There's the x squared plus, now instead of y, I'm putting 2x minus 3 squared equals 27. So it's quite similar to last time now. The method's going to be the same. So I'm going to expand that bracket, which will leave me with 4x squared minus 6x plus 9. Put together what I can. So I've got 5x squared minus 12x plus 9 equals 27. Now what was next? Okay, I need to make it say equals 0. So if I subtract 27 from this side, I must do it to the other, which will leave me with negative 18. So I've got 5x squared minus 12x minus 18, and that does not factorize. So this one was on a calculator paper, and it asked for your solutions to 3 significant figures. So by it asking for that in the question, you should really know that you're going to be using the quadratic formula or something similar in order to solve it. So let's use the quadratic formula. We do need to know this off by heart by the time the exam comes around. So it's negative b plus or minus the square root of b squared minus 4ac over 2a. I'm sure quite a lot of us can recite that. If you're not confident, just learn it. Keep writing it down and eventually it does stick. Okay, you know that a is the coefficient of x squared, so that would be 5. b is negative 12. And c is negative 18. Be careful you get the negatives in. And now be careful when you put them into the quadratic formula. So it would be negative, so minus negative 12. Plus minus. I'm going to tidy this up at the end. I'm just going to put them in for now. Remember, if you want to do negative 12 squared on your calculator, make sure you put that into brackets. I'm sure your teacher has told you that if you do not put those brackets in, the calculator will do order of operations. It'll do 12 squared, which is 144, then make it negative. So you'll end up getting minus 144, which is not what the answer to that is, because negative 12 squared is positive 144. And then we've got minus 4 lots of a multiplied by c, which is negative 18. And that's all divided by 2 lots of 5. Let's tidy that up a little bit. So that would just leave me with 12 at the start, plus or minus. The thing inside the square root here is called the the discriminant. Again, you'll see that at A level. And we can use the discriminant to work out how many roots an equation has, how many solutions it has, or whether it has no solutions at all. So it is quite a useful thing to use. You don't need to know that for the GCSE content, but that's just something that you will come across. I could simplify what's in here. So negative 12 squared, subtract 4 multiplied by 5 multiplied by minus 18. And that's all going to be divided by 10. I'm just getting my calculator. And brackets, negative 12 squared. And I've got 504. I do always like to tidy up this equation so it's nice and easy to type in. Remember, this is what's giving me the x values here. So my first x value will be 12 plus square root of 504 divided by 10. And it wanted 3 significant figures here, so that'd be 3.44. And my second x value will be given to me by 12 minus 504. And I've got minus 1.04 to 3 significant figures. So they're my 2 x values. Be careful here, because sometimes when we do the quadratic formula normally, we're just looking for the 2 roots of the equation, it's 2 solutions, but I'm doing a simultaneous equation, so I want to also work out what the y values are. So we're not quite finished. So my equation, I rearranged it at the top to get y equals 2x minus 3. So I can substitute these into this equation in order to get their y values. So 2 lots of 3.44 gives me 3.88. So there's my first coordinate where the circle and the line would intersect. And minus 1.04 multiplied by 2, subtract 3, minus 5.08. I'm just going to check that one again, because it's always good to check over here. Make sure you typed everything incorrectly. Minus 5.0, yeah, I'm happy with that. Okay, so there's my 2 solutions. There are plenty of those questions in online. Use the websites, use Hegarty Maths, and use your teacher, and enjoy it. Thank you.